Hi, Algebra 2 students, and welcome to a Unit 6 series video problem. In this problem, we're going to work on finding what we call the partial sums of an arithmetic or geometric series. This is kind of the basic idea of our unit, finding the sum of either an arithmetic or geometric series. So before we dive into this, let's go ahead and review the two formulas that we've learned. Okay, so we have the arithmetic series formula. And remember, that kind of started with that idea of are you smarter than a 9-year-old with Carl Gauss. And remember what Carl Gauss found is that if you pair up your numbers, so if you take the number of terms, which is what n means, and divide it by 2, that can figure out how many pairs of numbers you can make. That if you sum the first term and the last term in the series, then each pair would sum to the same amount if you match them up that way. So that's the arithmetic series formula. And then the geometric series formula is a little bit more complicated to derive. So I'm just going to write it here, but that involves taking the first term times 1 minus your common ratio to the nth power and dividing that by 1 minus your common ratio. Okay, now partial sum, think about what the word partial means. It means part of. Because series can go on forever. We see this series starts as 4 plus 7, and the dot to dot means it goes on forever. Partial means we're going to stop at some point, okay? And that point is going to be based on what they ask us to do, okay? So let's look here at example 1. And in example 1, we're going to find the partial sum of the series that's listed there if we have an arithmetic series, okay? So if this were arithmetic. So one thing I like to do is list out the things that I need in order to accomplish that. I need to know how many terms are in the series. I need to know the first term, and I need to know the last term, which in this case would be term number 48, okay? Because I'm really adding up 4, which is the first term, 7, the second term, all the way up until I get to whatever that 48th term is, okay? Some of these things we know just from what's given. We know that we're finding the sum of 48 terms, so that's what n is. We clearly can see that the first term is 4, but the one thing that we have to go and find before we can complete the sum is the 48th term. And remember, to do that, what we need is our explicit formula that generates terms in our series. And that's something that we learned in our first semester, and it's coming into now our second semester. So remember an explicit formula. If we take our first term and add, because we're arithmetic, the difference, n minus 1 times, that will find a term down the line in our series. Okay, so in this case, my first term is 4. The common difference would be 3 from 4 to 7. And I need to make 47 jumps to get to that 48th term. That's what n minus 1 would be. And if we calculate that, that would end up being 145. So that last term, if we're arithmetic, is 145. Okay, now if we put this all together, okay, we can now set up our sum. So S sub 48, if we have 48 terms, we could pair them up into 24 pairs, which is what that part of the formula generates. And each pair would sum up to the same thing. It would sum up to the same thing as 4 plus 145, or 149. And if you think about it, let me just write up here u sub 47. Oops, sorry about that. U sub 47, if I go 3 before 145, is 142. 4 and 145 add up to 149. 7 and 142 add up to 149. So that's why this formula works, is because it's really pairing up those terms, first and last, second and second to last, third and third to last, and we know how many pairs there are. So by multiplying this all together, we can find the total sum. So our answer here is 3,576. Okay? All right, so that's if we're arithmetic. Now, what if we're geometric? Okay, well, let me come down here and rewrite the series so I don't have to keep scrolling. This time, we're not finding the sum of 48 terms. That would actually be a really, really large number if you think about it. We're finding the sum of just 14 terms. So again, I kind of like to take inventory of the things that I need to put into that formula. So for the geometric series formula, I need a first term, I need a common ratio, and I need to know the number of terms. Those are the things that go into that formula. Again, our first term comes from the given information. And so that first term is going to be 4. The common ratio, remember to find a common ratio, we always take, sorry about that, a term and divide it by its previous term. So my common ratio is 7/4, or you can make it into a decimal, 1.75. Might be easier to enter into a calculator that way. And my number of terms is 14 because I'm finding the partial sum of the first 14 terms. Okay, I kind of like the geometric series formula better because I don't have to do work all the time. I don't have to do anything like we did above with the arithmetic. Remember, we had to find the last term. We don't need to know what that last term actually is to find the sum. So it's a more complicated looking formula, but it actually might be a little bit easier to calculate with based on what goes into it. So now if I set up the sum of my 14 terms would be what I get when I take 4 times 1 minus 1.75, the common ratio, to the 14th power, because that's my number of terms, divided by 1 minus 1.75. And we recommend just one calculation. Type this in exactly as it appears on your screen there. And if you do that, you should find the approximate value of that sum would be 13,469. And I'll go ahead and round to 3 decimal places. We either do 3 or 2, usually 0.748. So that partial sum would be this number if we were geometric. Okay, so hopefully this review is kind of just the basics of our unit. Feel free to check in and watch another video to learn more about arithmetic and geometric series. See you soon.